Hello, guys. Welcome to today's stream. Um, Welcome to today's live stream. So today we are going to be talking about control flows, right? In Rust, what they are, and when and how to use them, and generally why we use them. So this is going to be my first stream. I'm going to have another stream today later in the day. I think that would be evening time, and where I'll talk about a more interesting subject based off of a tweet I saw here on Twitter. But basically, today we are going to um, look at expressions versus statements. Then we'll talk about control flows, right? The if let, match, loop, while, um, while statements, if else, um, let else, and a whole lot of them. We're going to look at for loops, ranges. We're going to look at while loops. We're going to look at loops, right? So I'll try as much as possible to make the, the live stream interesting. I know I usually say my live streams are not going to take that long, and it ends up taking like hours, right? But I'll try my possible best today to make sure that the live stream today doesn't take that long, and then we have like a reasonable session that's engaging and not um, too technical or easy for one to understand, right? Yeah. So without rambling so much, I'll just go ahead and set up my environment. So we have a repo for this series, that is the Rust by example series. We've covered um, custom types, covered type conversions. We've looked at variable bindings. Today we are going to be looking at two things in the Rust by um, example series. So let me pull up that doc. Let me pull up the doc. This is Rust by example. Yeah, looking at this Rust by example. So we've looked at primitives, custom type variables. We've also looked at types, and we looked at types and variables together. We also looked at conversions. So today we are going to be talking about expressions as well as control flow or flow of control. We're going to be looking at if else, we're going to be looking at loops, while, for and ranges, match, if let else, while left. I'm going to be going ahead to explain when to use them, when and why to use them, and how to use them, right? So that's what we are going to be looking at today in this series. In our next series, we'll be talking about functions. We spend a lot of time on functions, and functions part of every language, right? To understand the databases, right? Function language. Okay, let's get right into it, right? So, guys, once again, welcome back to my live stream. It's always surprising seeing people join me on these live streams, to be honest. I usually start the live stream without expecting anybody to join up, right? But seeing you guys here, I'm really, really, really happy that you guys press the button and say thank you for letting me join on my live stream. And I really do appreciate it, to be honest. And guys, please, um, I'll be sharing the link to the live stream on YouTube. Those that if it is not bright enough, you can always go to YouTube and you'll see a brighter version. I don't know what's wrong with my X and why it's always kind of blurry. Complained about that. So I'm just going to add the link to the chat, and then hopefully everyone should be able to see. I also appreciate if you can leave a comment, maybe a comment, ask questions. You can always ask questions. That I'm more than willing to answer your questions. So I want my live streams to be kind of like a conversative, or let's say conversation between me and people that you know come on the live stream, right? So that's the purpose of doing a live stream in the first place. To have like a dialogue, a conversation. It's something I'm not doing correctly. If I'm correct, right? It's something I'm doing wrong, or that could be a better way to do something, and you can draw it to my attention. Right? Nobody knows it all at the end of the day. That's why I always encourage you guys if you drop a comment, say something on this thing, right? I will not bite, to be honest. I won't bite. So I just once again will say thank you so much for joining me on this thing. And we'll get right. Before we go ahead, I will create a file. We always do. Create a new file. I'll call it expressions, and pattern match. I'm trying as possible to make this file explanatory. So I will leave that main.rs guy here. Comment out type conversions because we're not doing any type conversion today. And I'll add a comment here. I'll call it expressions. It's and matching patterns. Right. So in our this case, we just create a public function. Express just a print line. So, so we're able to use this function in main.rs. Yeah, express pattern, save, and I go run. Yeah, so I should get welcome, guys. So yeah, so let's dive right. Start from expression and start from expression and start from statements, move cover expressions, and then move on to statements, right? So Rust is an expressive language. Right? Rust is an expressive language, which means everything that uses a value is an expression. So now we look at the difference between a statement and we look at the difference between a statement and an expression, right? So now, a statement or statements are instructions that perform an action but don't return a value, right? They are kind of like workers who do a task but they don't bring back any pay or something like that. Yes, exactly, Captain. Right? You're more than you're more than correct, to be honest. So, this concept makes it Captain said this concept makes me truly appreciate the fact that concepts in programming are transferable and um, most building blocks are similar. That's the thing they say about learning one language and being able to easily transfer that knowledge to another, right? That is why it's also good for you to learn the basics of any language, like focus on understanding it from the grassroots, right? Now, when you have for any reason whatsoever, when you want to learn a new language, it becomes easier for you to transfer the knowledge of what you know from one language to another, right? They don't just gloss over the basics and start writing React, right? Coming from a JavaScript background, you have to learn JavaScript so well that writing React will not be difficult for you. And taking that knowledge to another language becomes an ease for you, right? And because at the end of the day, it's the same concept, just different flavors or different syntax. Yes, thank you so much, Captain. For back to what I was saying, I said statement is like sending a worker that went to work, but he didn't come out with any pay, right? While an expression is like a worker who went to work and is coming back with pay, right? So now let's look at some examples. So for instance, let's say I say let x be equal to 15, right? Um, okay, and um, x equals to 15. And one thing to take note of is expressions always end with semicolons, right? Because always end with. So then I can go ahead and say let's x plus 1. Say this. Um, so basically, what's happening here is would evaluate. So this statement computes to give us 16, and at the end of the day, um, you know, it gets discarded, right? Because we're not using it. You know what I mean? So it gets discarded at the end of the day because this is a statement, right? We're not returning anything. It's just there. So I'll add comments here. So this is statement, right? So this does not return anything. It just computes and gets discarded, right? But now let's look at an expression. Expression. Now, expressions on the other hand, like I said, they are like workers who go to work and come back to pay or something. Um, in Rust, even the block, like these blocks, these curly brackets, are expressions in Rust, meaning you can use their value somewhere else, right? They return something, so you can be able to use their value somewhere else. An example of this would be, let's say, let's y equals to our brackets. Then in here we say let a equals to 10 and now say a plus 5, a plus 10. Yeah, so do that, add semicolon at the end. So if you take a look, right, you'd see that on line 9 we don't have any semicolon ending it. So this means it returns 15 as the block value, as the value for this block, everything in this block, right? If you take note, you see where I then added the semicolon, which is outside of the block. So the compute would happen here and would then return the value of 20 y. So if I go ahead and I print y, you would see that we'll get 20. So I'll take this guy out and I'll say value of y. That's y here. Save. Find this guy. So just go ahead and run this. I will run. This should give us 20. Exactly. So if you take a look at, you can see that we have 20 here. So let me close this guy. I'm not using E. Command B, sorry, on the Mac. So that's just basically shortcuts that I use to make things make life easier for me. One again I use is Control A, right? So Control A to automatically select everything. And Control E, Control Command B, sorry, Command A and Command B to open the tray by the left side, and so many other shortcuts I use just to become productive and faster and all that thing. That's by the way. If you take a look at the terminal, right, you see how we have the value of y is equal to this. So what has happened here is the compute has happened inside this block, right? Remember I said expressions, these curly brackets or these blocks can also be considered as expressions, right? So what has happened here is that we have done this compute here and we did not add a semicolon here. We added it outside of this block, and at the end of the day, that value, that compute that was done inside here was then returned and appended to this variable y, right? So basically, that's like everything you need to know about expressions. So once again, statements are instructions that perform an action, but they don't return value, right? Like I said, they're like a worker that went to work and he did not come back with pay, right? While on the other hand, um, expressions are like workers that return with something meaningful. In this case, cash, right? After they've completed their job. And also one thing to note again is that the coily blocks, like these coily brackets, written like this, right, can also be considered as expressions in Rust, meaning that we can use their value just like the way we are able to use y here, we're able to plug it, we can use it for something else, we can use it to do some calculations and all that, right? So that's one thing to take note of when it comes to expressions and statements. So you can already see how similar this is to concepts from other languages, right? And maybe coming from a JavaScript background or something, you can already see how similar it is. So that's why I always stress on basics, right, of every language. It is very important that one learns the basics of any language that they've decided to get into. Okay. So next, would oh my god, sorry guys, I didn't know my this music was still playing. Okay, I'm so sorry about that. I'm so sorry. I always forget that my music is playing. Um, okay, okay, back to what I was saying. So now we'll go over to pattern matching, right? Um, or like I said, we'll go over to flow of control, right? So according to the Rust by example book, he says it's an integral part of any programming language. Are ways to okay, an integral part of any programming language are ways to modify control flow. That is the if slash else, for and others, right? So I would be talking about them. You can still visit the Rust by example docs to read more, have more in depth into them. But what I'll be doing is I'll be doing my very best to explain them in such a way that they are easy for one to understand and quite relatable, right? So now, we're going to talk about if and else, right? So I'll just put a comment here. I'll call it control flow, and after that I'll say if and else. So just to add nice comments to make this whole thing um you know easier to understand. If and else. Okay. So now the if and else statement, or the if and else pattern or control flow is not just a control structure in Rust, right? It is something that can be considered as an expression, right? And what this means is, like I just said, is it can evaluate to a value. So your if your if and else can evaluate to a value, which makes it really powerful when you're doing things that have to do with conditional assignments, right? But one thing to take note of is that because it evaluates to a value, the block in an if expression must return the same type. So if it evaluates to a value, it must return like the same type. If you have multiple conditions, for instance, if you have like an else if statement, but for a very, very complex case, it will be better for you to use something like um, a match statement, right? Instead of the if and else. We'll get to the match statement, soonest. I think it's the next thing I'll be talking about. But basically, if the if statement is not just a control structure, it is also an expression. And the reason it's an expression is because it can evaluate to a value. That means it can return something, right? But whatever it is returning must be of the same type. Um, you cannot, how will I explain this now? Um, you cannot try to return a type of a boolean and also a type of a string at the same time, or an integer, right? So let's look at some code examples. So let's say we create a variable called let is Rust cool, and we'll set this guy to true, which is a bool, right? A bool. So we'll now create our if else statement. So we'll say if is Rust cool. Here we'll just say absolutely, absolutely, mhm. And we'll create an else here. We'll say else you you must be joking, must be joking. Then coming down here, I can then use that to say print line, and in here I would as this I'll say my message. Okay. So now okay. So I'll create a variable for that first. Right. So this if now has to evaluate to something, right? So I would say let's say we use let's message message equal to this. So whatever it is here. So now this is now going to be a string type, right? I cannot just remove this now and pass a number. So if I cut this and I say 10, right? This would break, right? It will say, Ross will tell you if and else have incompatible types, expected a string slice, but found an integer, right? So this takes me to answer your question, Captain, where you say, do the conditions in if statements have to be Boolean? No, they don't have to be Boolean, right? But what they have to do is they have to return. I'm not sure I understand your question correctly, but the um for the fact that the variable on line 16 is a boolean does not mean that the different blocks have to be booleans, right? The only thing that matters here is that they have to return the same type, as you can see on my screen, right? I explained, I said the if else statements cannot evaluate to different types. It must always be of the same type, right? So now if you take note, you will see that I passed an integer here, and it's already telling me that if and else have incompatible types, expected a string slice, but found an integer, right? So that means this will not work. This will not fly. So, but if I go ahead and I pass back what I had there before and I save this, you would have automatically seen that um, my, you know, my error has gone, right? Another thing again is I can change this through to something like, let's say, let it be 10, right? And I would, let me save. You see it would fail, right? Because it's saying that is Rust cool, right? Expected a boolean, but found an integer, right? So at the end of the day, we have to always evaluate to the same type. If I change this, so if I cut this and I pass something like let me say 1, and here pass something like 10. So this is me experimenting at this point. Oh, okay. Okay, mismatch type, expected a boot. Okay, so Captain, I think the answer to your question is, if I understand your question correctly, because I'm trying to understand your question. You said, do the condition in if statement have to be boolean? I think I would say yes, right? I think I would say yes because from what I had just tested now, right? I tried using integers to evaluate, to to test this out, and I'm getting this error saying, mismatch type expected bool but found an integer, right? So I think that's, it has to, the condition in the if statement has to be booleans, but it doesn't affect what is being returned, right? I don't it, it should it doesn't affect what is being returned, but everything has to evaluate to either true or false. I don't know if that answers your question, or you can just let me know if I've answered the question, Captain. So I'll take this back to what we had and I'll save, right? But the crux of everything is that at the end of the day, everything we have in our if else evaluates to a value that is stored in message. And this value type is a type of a string slice. Exactly. It has to be a boolean. Yeah. So now I think I even missed that initially in my explanation. But thanks for asking that question. Right. It really helped me look at it in a different way. Thanks, Captain. So now I would save. And when I save, I would run this again. Let's see. So you can see that um, it evaluates to the first part, which is true, right? If I change this to false, it will evaluate to the second part, right? So let me test that out. Run this again. Exactly. So we have the second part running. So once again, Captain, thank you for asking that question. It actually helped me look at the whole thing in a different way, right? So I thank you for asking that question. So at the end of the day, um, it has to be a boolean, right? But the major thing to take note of is that the if else statement is not just a control structure, right? It is not just a control structure. It is more of um, you know, something that can evaluate to a value, right? That can be used in other parts of the code, right? So that's that for if and else. So next, now we'll move over to match. Let's move over to match. On the comment, I'll say mtch. All right. So for match, right? Like if you're new to Rust, you might not know this, but match is like is what I say the Oga Pata Pata of pattern matching, right? Is the king of a lot of people make use of it. It's something I found very fun to use when I started playing around with Rust, right? And one thing about it is that it is an exhaustive pattern, right? Which means it would force you to handle all the cases, right? All the possible use cases for a particular condition at compile time, right? This particular functionality of the match helps us to prevent a whole lot of category of bugs. It helps us prevent a whole category of bugs, right? So match is very versatile. You can use it with um, literal values. You can use it with enums. You can use it with you can even bind it to variables. You know, and it can really get confusing sometimes, right? Because you can use it in a lot of in a lot of ways, right? So one of the reasons why you might want to use it is because it is exhaustive, right? Which makes it perfect for enums like the option and the result enums. um, you know, it is also very readable, right? It's quite readable, in my own opinion. Um, you know, it's quite readable because it helps you because of the kind of thing it helps you do, right? It helps you handle um, a lot of logic. Yeah, you can say it seems yeah, Captain. So Meanwhile, Dara, thank you so much. I appreciate the comment. Yeah, Captain. So you can actually say it seems like switch statement, but in switch statement, a switch statement doesn't force you to handle all the cases, right? You can correct me if I'm wrong, though, but I know that you can handle some cases in a switch, and you can leave out some. But yes, it's kind of like switch statements, because you have the case, you have the action parts where it does stuff, then you have the parts where you check a particular condition with the different cases in a switch statement. So yes, technically, right, it works like a switch statement. But I think one thing that makes match much more, and is based on the way Rust is match forces you to handle all the cases, right? It kind of it forces you to handle every possible case at compile time. You understand? So it is, and one thing again is that it is extremely readable, due to the amount of the level of complex branching logic that it helps you handle. Right? I'm trying to you know gather my words here, right? So one thing that let's look at an example. So we'll use something like an enum to look at um an example. So we'll use like a weather enum, and we know that the weather can either be rainy, can be sunny. So let me just write it out. So let's say we have like an enum. So we use the enum keyword, and we'll do this to say weather, right? And in that place would have like rainy, we'll have sunny, and we'd have something like although even if we don't have snow in this part of the world, let's just say snowy. Okay, so this should be capital letters. So it should be capital letters, sunny, snowy, right? So now, let's say today, let today be equal to weather. Let's say today's weather is um, let's say is rainy, right? Let's say today's weather is rainy. Let's just do it like this, right? So here now we can now go ahead to use the match statement, right? You can say M match. So match today. So like Captain, like you said, similar to switch statement, which is true. You can say let's match today. We'll then say we'll create our block. And in this place now, we'll now do our whole pattern matching, right? So we can go ahead and say if weather weather is rainy, mhm, we'll then use an equal to and an arrow sign, and there we'll say it is rainy. So let me look for an emoji that represents rain. I don't know, this MacBook and getting emojis sometimes it's quite difficult. So I'll say rain. Which one will I use this? Okay, I'll say it's raining. Right. So this is the first part, and I'll end it with something like this. No, comma. Sorry. Right. Then I will go over to the next one. So I will say whether. So you can see how I'm handling all the cases, right? So I'll say whether snowy. So I'll look for an emoji of snow. Getting this emoji is always difficult. I don't know why. Snow. Snow. Say um it's snowy. Get a jacket before you die of hypothermia. That's not necessary. Okay, get a jacket. Let's just leave it at that. All right. Then we'll go over to the last one, um which is sunny. So weather sunny, or we can say Once again, let me try to get the emoji. Sun. It's sunny today. So you can already see how we are handling the different right cases, and you can begin to see how simple and easy to read it is, right? Compared to switch statement. So let's even let's even compare it. Let's look at Java. Java. What's happening? JavaScript switch. Yeah. Let's look at JavaScript switch. Right? So, like Captain said, it's basically the same, right? You have the expression, and you have different cases and all, right? But yeah, exactly. So you can see that it's more readable, right? But you can basically compare it, right? So let's do versus mtch Rust. Okay, exactly. So yeah, this is AI saying JavaScript switch statement is similar to Rust match, but is considered less powerful, right? So they are saying the switch statement is considered less powerful than the Rust match, as match allows for more complex pattern matching beyond simple equality checks, right? Enabling you to match on data structures like tuples and structs and even enums, like I just did, right? If you take a look, I just matched on enums, right? Um, you know, why switch is typically limited to basic value comparisons, right? So yeah, they are similar, but at the end of the day, pattern matching handles more things and it is easier to read, right? Easier to read. So Captain, thank you so much. I really appreciate um you guys being here and engaging. This is what like the stream should be like, right? So one thing I can do again is I can actually expand on the rainy stuff, right? Now I've told you that it's rainy. I can also go ahead and tell you, don't forget to come with your umbrella, right? So I can cut this out and wrap it in a block. So I can cut this and wrap it in a block, paste this here, and come down here and nope, I think I made a mistake. I would say print line. Mhm. Um, so I would say, what am I doing? I'll just cut this out. What am I doing today? So it's running print line. Do not forget to carry an umbrella. Right? So I can do this and yeah. So on that thing again, I noticed I didn't put print statements here. I don't know how I made that mistake. That was a crazy mistake. Uh-huh. Okay. So snowy, very sunny, never constructed. Hmm. Okay. Undo, remove this. Okay, control I. Okay. Print line and wrap this here. So rust is white somehow sometimes. Somehow sometimes. Oh, what am I doing? So wrap everything in curly brackets. Same for this guy. And let's see. Yep. So take this out. We don't need that there. Same for this. Exactly. So yeah, rust can be pretty stubborn sometimes. But yep. So we can do this, right? We can do this to kind of like you know, have more, you know, print statements here to pass more information, right? So this is just like the basic way we can do this. Let's also go ahead and handle a more complex state, right? So we'll do that with a number where we'll check, we'll do something that there's something called range. We'll check for a range, we'll check for a number, and we'll also handle a case whereby we don't have any number at all, right? So since Snowy was never constructed, and let me run this first and see what we get. So cargo run. Okay, must be joking. So for rainy, it's rainy. Don't forget your umbrella exactly because that's the part that matches, right? The rainy part. So let's take it a step further and handle a case where we have a more complex pattern. So let's number be equals to 400. So this is an I32, and let's say match, give space just to make it readable. So match, and here we'll pass our number because we are checking for numbers, right? So we'll say number, and in here we want to check. We'll say one. If one, right, we'd want to print line, and we'll say print it's. So if the number is one, we'll say it's one. Uh-huh. And then I'm always using that. Don't use that. Use comma. Then we'll go to the second part, right? Where we now say from two to let's say from 2 to 200, right? So we'll say um print line. The number is between 2 and 200. So this is range. We'll talk about range later on. Then we have the part where we handle a situation whereby we don't have maybe we like, well, the situation whereby we try to handle a missing value, right? Maybe a value that a condition that we did not handle in the first place. So we can say n, use n, and we'll just say print line, and we say got. So this would handle for general situations, right? We save this and let's run the code. So you can see that what we got here is what got 400, right? Let me take out this stuff. I don't know, it should be blocking you guys. Okay. So yeah, not really like if you're talking about um the n exactly. So it's kind of like handling cases. Yeah, you will call it a default case, right? You can call it like a default case. But basically, the way I look at it, the way I see it is, I see it as, let me use this to handle the cases that was not handled in the first place in my match. So yes, you can call it a default case, right? It can also be used to handle a situation whereby um something is missing, right? Maybe there's an error or something. You want to use it to handle that particular situation. So yeah, it's kind of like a default case. Yeah, it should be a default case. It should be. On that side, I think I can also say it's kind of like a break, but not really. Not really. It's not. It doesn't have anything to do with um, you know, with you know, breaking and all that, right? Yeah. Anyways, okay. So, um, okay. So as I was saying, so captain, right? If we want to um handle a default case, because I was actually thinking of it, right? I think there's a syntax for that, and it's kind of like underscore. Use an underscore. So let me check. Match. So this is match, and then come here. Let me see. Look at something like an inum. Nope, nothing here. Structs. Look at guards. Yeah. So something like this, right? If you take a look at line 7 here, so where you see the underscore, right? So this underscore is going to represent like a default case, right? So this particular one would represent like a default case. I don't know if that answers your question, but it's kind of like a guard, right? So that's why I said it's not really like a default. It's not this what I did here is not really like a default case. This is like a kind of like a catch-all case, right? So what a default case would do in this case is for things that are not available, that condition that's in a situation whereby we don't even have a number in the first place. Yeah. So yes, yes. So I was actually thinking about it for a while, for a moment. But yeah, then again, there you have it. So this is like a more complex pattern matching. And here, if you take a look, we are doing some things that have to do with range. We'll talk about range. Um, but basically, what we've done here is what we did here on line 45 is binding. So we bound this value to this to n, right? Because we didn't specify, right? So if we wanted to handle like a default case, um, like I mentioned, what like I showed, what we'll then use is an underscore, right? We'll use an underscore and something like this, and we'll just say um let me say what will I use now? Got something else, right? So let me see if I change this to kind of like a string or no, let me undo. Yeah, exactly. Yeah. So okay, so let me say I'm just trying to play around with this here. So I would call this a text, and I would say it's a type of, let me just pass temperature there as string slice, and okay, save this. Unreachable pattern one, unreachable by default, and I'll pass this here text. Okay. So of course we'll have an error here because we have miss, and this is the thing I love about Rust, right? At every point in time is always, so I'm using something called Rust Analyzer. There are some guys that will say you're supposed to use NeoVim, you're not supposed to use all this stuff, but right, what I always tell people, or what I tell myself is I'll do what works for me. I'll do what helps me to learn the best way I can. Then when I feel like I've gotten to that elite status, right, I can start using NeoVim and with the rest of you guys. But one thing Rust Analyzer does for me here is I don't have to compile code all the time in order for me to see errors, right? I'm already seeing it here on my screen that I have mismatch type. Of course, 1, 2, and 200, they are integer types, right? So they are mismatched. So the thing I can do here is I can just comment this out, right? I can comment this guy out and save, right? It will tell me, of course, that it is unreachable. The reason it is unreachable is because this guy has already matched the pattern. So if I change this guy from being n and I change it to something like let's say humidity, right? Humidity, and I save, cannot find the value n in the scope, blah blah blah. Why is it still giving me n? Okay. I don't need that again. So I'll put all this back, right? It's humid. I'll just say it's humid. I'll save. I should not have that error again. Unused variable humidity, blah blah blah. Okay. Pass you here again. Humidity. Okay, save argument never used. Argument never used. Argument never used. Hmm. Okay. Oh, I see. I see why that is happening. Let me. Hmm. As a snake case. Oh my God, Rust. So he's now saying I need to use a snake case, but this is just a warning. Okay. But at the end of the day, it will still evaluate to a type of string. So it will definitely go ahead and tell me that this is unreachable, right? You can see the one in here, unreachable pattern. Um, yeah, because line 46 will run, right? And it will match the type, which is type of string slice. So yeah, so Rust is like that, where the compiler basically guides you all the way, right? It's kind of like a a guide that keeps guiding you so you don't make mistakes. It keeps guiding you. Sometimes it can be very frustrating, but yeah, you get the point, right? So I'll just take this back to what we had it to be before. Have number, and I will just leave this here, right? Um, I'll leave this guy here just for the purpose of learning, right? But we have a one in there saying unreachable pattern. Yeah, and that is because we already matched it here on line 45 with the end type, right? So it's kind of like passing a variable, right? So number is represented here as n, and we know that the number is a type of I32. So we'll just say got a number. But if we put something like, let's say 150, it will tell us that the number is between 2 and 200. So let's say 150, and we save this and we run the code again. Cargo run. Yeah, so it will tell you can see it here. It says the number is between 2 and 200. If I change it to 1, I save, it will tell me that it's 1, right? Cargo run. So it tells me it's 1, right? So you can begin to see how we are using this match to kind of match different all these different cases, right? So for a situation whereby I don't know what the value is, or maybe I just want to use like a variable or something like that, I can just pass something like n, which will evaluate to number, which is the expression that I'm using to check for the different arms of this the pattern matching, or the match pattern, and it would automatically evaluate for this line, right? But if I comment this out, let me comment this out and take this to 400 and save, right? So you see automatically we have gotten to this line, right? So if I run this again, I'll got something else, right? The reason I'm not getting that one in again, where it's telling me unreachable arm, is due to the fact that none of these other arms have evaluated. The guy that would have evaluated to being true, I commented him out, right? So if I save this and I run this code again, you see got something else. Right. So this is like kind of like the default. This is like captain, the catch all pattern, and it handles like default cases in this case. So I will just leave that there for and captain, thank you so much for mentioning that. I really do appreciate, because that skipped my mind, and it is a concept that is very important to talk about. So yeah, thank you for that. So I'll comment this back, and let's move forward. So next we'll talk about iflet. So iflet is, if you've followed my previous streams, I use iflet a lot. The reason I use it a lot is because it helps me to unpack enums like options and results, right? So I'll be having another live stream where I'll talk about, I think it's today, maybe today, this evening, I'll be talking about options and enums, and the difference between them, their similarities, why we use them, when you should use them, and when you should not use them, and everything. And all this is coming from a tweet I saw on Twitter. Someone made about how um how good Rust handles errors, right? Because Rust doesn't give us null, right? So it then forces us to use things like option and result to handle our errors, right? So I think I'll be streaming about that later today. But I use options a lot in my data structures and algorithm series, where I use the iflet to unpack the option, right? I use it to unpack a value that is in the option. So the Now, why am I talking about iflets? Iflets are similar to match, right? But they are more optimized and they are simple to use, right? Um, you the situation whereby you want to use an iflet is where you care about only just one value. You just care about a particular value, and like I mentioned, they are perfect for unpacking enums like options and results, right? And it is used for the case whereby you are only interested in one specific case, right? So, for instance, I will use an iflet if I'm only interested in one, right? No need for me to write the entire match, statements. I'll just, use an option and use an iflet to unpack the value because I know that I will definitely get one from there. And then option also gives me a second value, which is none, to handle an error case, similar to result that, takes maybe a string or a boolean or something, and also, um, you know, it takes, I think it's okay and error, right? It returns an okay for success, an error for where there is, an error. And a practical use case of that is like when you're making like an API call or something, right? You just wrap it with a result type. If it's going to return a string, it returns a string or something, and at the end of the day also returns an error for a case whereby, you know, the API call was not successful, right? So yeah, I know I'm digressing. I'm digressing a little bit, but you get the point, right? One of the major reasons why I use or we use iflet is to reduce boilerplate code. It tells the reader that, or whoever is going through your code, that you're intentional about ignoring other cases. You're just interested in one case, right? So let's look at an example. So I would let me organize this code a little bit. Cut this guy. Value of y. I'll take it. Yeah, here it should be here. And semicolon. So once again, if you want to format your code, so if you take a look, you'd see how scattered this guy is here, right? It's not aligned. So one thing you can do is to use Rust cargo FMT, so cargo format, basically. And once you do that, it's automatically formatted. So you can see this has aligned. Exactly. So yeah, so it's like a less verbose way of handling a specific case. Exactly. So I would say it's like a way you handle just one case. So if you're interested in only one, right, and there's no need for you to handle all this the rest of these guys, so you just throw, instead of using match that is quite verbose and long and stuff, you just use an iflet, right, and you use it with an option. And the reason you use it with an option is because the option returns, it helps you to handle an error case for a situation whereby the value is not available or for some reason it wasn't available. So if that happens, the non-block will run, but if it is successful, then the some block will run. So I think I should have my previous streams. I use it a lot, right? When I do things like, when I think I used it when we were building a binary tree, right? And how when we did things I had to do with depth first search and all that. I used that there. And yeah, so it's, you have to use it with options, because it helps you to handle, because remember, you are saying, I'm sure of what I want, I know what I want, I am expecting only this value from this place, right? So since you're saying you know what you want, there is need for you to be able to handle errors, right? Because like we all know in software, things happen, right? Code can break, something can happen, and the value that you're so sure of getting, you might end up not getting it. So that's where option comes in, right? To help you handle the case whereby it is not available. So when it is not available, there's a silent none that is returned, right? To prevent your code from breaking, something like that. So yeah, that's it. So let's look at some example. So add the comments. We'll say if let's. So here I would say let's mm, maybe age, let it be equal to um sum. So I'll just use sum. So I can use sum and I'll pass my value, and Rust would automatically infer the type for me, which is an option type. So just say let me say I am 38 years old. I know I'm not up to that. But you can automatically see that my Rust analyzer is already telling me that it's an option type, right? So if we go to the documentation, let's go to Rust documentation and look at what option is about. So option Rust, option example in Rust. So we can automatically see that option, which is sometimes is desirable to catch the failure of some parts of a program instead of calling the panic, right? This can be accomplished using the option enum, blah blah blah. So the option takes a generic T enum of two type. It has two variants, the which is the none to indicate, like I mentioned, the failure or lack of value, right? Or some a tuple struct to wrap a value with T type, right? So like I mentioned, the none helps you because you've said, trust me, right? I know what I'm doing. I am only expecting one value from here. I don't need a match pattern to handle this. Just give me that one value, right? Fine. You have to wrap it in, like, an option enum, right? And this option enum now returns two things for you, like I said, some and none, according to the documentation. The none handles a case whereby the value is not available, right? And the sum value handles a case whereby the value is it was successful. It is very similar. This guy is very similar to results, right? But the only difference is that result returns okay and error, right? I don't want to go into that, but let's just look at it, right? So let's say results, you know, Rust. Hmm. So you can see here, right? So in the results, we have OK, which handles a successful case, and we have the error, which handles a failed case, right? So contain OK contains the success value, while this one contains the error value. So the two of them, the difference between both of them is like you have a box, right? And if you open the box, if there's nothing inside, you get an error yeah, like an error text telling you that there was nothing inside this box. That's how result works, right? But the box for none or options is not going to tell you anything. It's just going to be looking at you, but it's not going to throw an error. It would somehow in the background handle that error case for you. So that's like they can really get, like, initially I used to mix them up, right? In fact, at some point I didn't know when to use one and when not to use one, like, because they were so similar, and I didn't understand why we had to have two things that seemed similar, but had different variants, right? Right. So the result type has like the OK variants and the error variants, right? Options has none and some, or some and none, and all that. So I struggled to kind of um understand why we had them, but believe me, they both have their different use cases, right? Results is something you use for instance, let's say you're passing a file, right? You want to read a file and get the things in the file. So you use option to check if the file is even available, right? Then you will use the result in the case whereby you're trying to you use the result to check if you can actually pass the values in that file, if that makes sense. So I know I'm being too explanatory here, but I'm trying my possible best to go really deep to pass like the idea. So let me not digress too much. Let's just get back to it. So here I can explicitly add my option if I want, or for the fact I wrapped it in some. Rust does something that they call type inference. So it has inferred it here, and it is now saying that since I wrapped it in some is a variant that comes from option, the maybe type is an option, right? The maybe age, sorry, is an option. So if I hover over this, you can still see the same thing I just said. There's none and there's some, the option type, blah blah blah. You can just read more about this, right? Um, yeah. Okay. All right. So now we have that. The next thing we are going to do is well, first, okay. So what I'll do is I'll first of all write this out. How I will use how I'll write like a match statement for this, and then I will go ahead to simplify it using the if let. So if it's a match, I'll say match maybe age, mhm, and inside here I will then say sum because I have to handle it with sum because it's an option type. So I'll say sum. I'll pass my age, which is what I want to get from there, and just a kind of like destructuring, right? Then I would say print line, and in my print line, I would say age is this, and I would pass my age, right? I made a mistake here. Hmm, okay, then I will then handle um so you can already see that Ross is already telling me that missing match none is not covered. So I have to handle the error part. Right. This is because I'm using match. So I have to, handle that part. So I'll use the default this thing to handle that. So I'll just pass like an empty tuple and that error will be gone. Exactly. Right. So this is how imagine the level, the not the line of code I have to write just to do this simple stuff. Right. So Captain said, okay, option seems like it will either return a value or none. While on the other hand, result will either return error or result. Okay, so yeah, you are very close, right? Option would either return a value, which is sum or none. So options have two variants, sum or none, while result has two variants, which is okay and error, right? So now, what it does is they are both similar. They are very similar and easily they are easily like you can easily mix them up, right? But the thing to no, it doesn't return anything. It doesn't return anything. So um, it is a silent error response. And like I said, I gave an analogy. I said the option, right? Option would either give you a value or it will silently return an error. So it will not return any error. It will just handle that case for you silently, right? So none, which is nothing, nothing is there, non-existent. But result, on the other hand, would return with an error message, right? So that is why you use it to handle IO operations, right? So I gave an example. I said you can use option in a situation whereby, let's say we want to read a file from the command line, right? Now, if we want to check, first of all, the first thing we'll do is to first of all check if this is that file with the name, with a certain name, is it existing, right? We'll use the option enum to check. If it exists, we'll use the sum to handle it because we know that that file within that particular name exists in our directory. Or if it doesn't exist, we'll use none to handle the failed case, and it will be a silent handle. Now, in a situation whereby fine, that file exists, we will now go ahead to pass the file, which is read the information that is in that file. So what we will use in this case to handle that situation is the result enum. Now, the result enum returns two variants. It has two variants, which is okay. Okay is for yes, we can read what is in this file, while error is for a situation whereby we can't pass the file, we can't read what is in this file, right? So now that will now come with an error message telling the user, kind of like user experience, right? So that tell the user that look, this file, like I couldn't read it, right? I couldn't pass what is in this file. So that's how both of them works, right? It's kind of confusing, but it makes a lot of sense if you really like dive deep into it to understand why we have two similar types or two similar enums that do the same thing, that do almost the same thing, but have different use cases, right? So I don't know, Captain, if I've explained. I don't know if I've explained. I've tried as much as possible to explain. But I don't know if I've explained enough. But I'll be having another live stream this evening where I will really, really, really dive into options and results because believe me, it confused me a lot. Right? It took me time for me to understand the use cases, when and how, or why I should use, you know, results, and when and why I should use options. Right? Okay, so Frank said, I think I saw somewhere that option type is when the absence of a value is not necessarily an error. Exactly. That's just Do you get? So it doesn't mean that okay, this value that is not available is an error, right? It's not necessarily, it doesn't necessarily mean that it's an error. But whenever you are using something like a result, it is definitely, you are definitely expecting it to be successful or it to be failed. And in a situation whereby that stuff fails, you want to tell the user, or you want to send an error message somehow stating that okay, this stuff failed, right? So, Captain, I don't know if I've been able to do justice to your question, but yeah, it's a very interesting subject, and in fact, I'll be having a live stream specifically on the subject of options and results, when to use them, why using them, why we should use them, and how to use them. And I'll even go ahead to implement a very simple program just to read a file from the terminal and all that. I'll do that. I'll have that stream today, later today, hopefully. So, please let me know if I've done justice to the explanation. And yeah, so I'll just move forward, right? And thanks, Frank. Um, yeah, thank you, Captain. Thanks, Frank, for that contribution. I really appreciate. So now this is an example. So I just showed an example with match. So at the state comment here, example with TCH, and now let's go ahead and now do this with the iflet. I love using iflet a lot because it makes, I'm in for anything that makes my life easy. Right? I don't like stress. So I use iflet a lot. I just use it, unpack the options, right? Unpack that value I need, and I just move on. I've been hitting my mic a lot. I don't know what is happening today, but I just use it to unpack my values, whatever it is I need, and just move on, right? It's I just like it so much. So let me go ahead and add a comment for um that. So example with if that. So here I will just say, first of all, I always like to first of all define the I'll first of all handle the case before I will then kind of like destructure it. I don't know if destructuring is the right word. Well, I'll use destructuring, right? I don't know if it's the right word. Okay. Unpacking, because in the documentation I know I saw unpacking. So use if let's unpack the value in an option. So let me use unpack. So I would say in this case, I would say sum, and here I have age, and in that place, no, 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 not that. Okay, say maybe age, and I'll just in here. I'll then go ahead and print. So I'll just print line. Uh, I'll say my age is this, and then I'll pass the age. So what I will do now is I will now equate. I will now say if let's, right, sum. So then that thing I'm unpacking, right, is what I will then pass into that parenthesis, which is in this case the age, right? If you take a look, I still use that age here, right? So that's what I used here. So you can begin to see how simple this is, right? I just got my maybe age. So this is maybe age here, and I'm already even printing, right? I don't have to write this complex long sum something and then do the where I have to handle it in a situation whereby it's not available at all, right? Like for the default case. So um, you know, I don't have to do all these complex things. I just have to use if let, and whatever value that is evaluated from this, I would unpack it using sum and passing the age. And you can automatically see that it already, like my Rust analyzer Rust already infers it for me, thereby telling me that it's already a type of I32, which is similar to the value I passed here. If I change this to something like true, right, it will change to a boolean. So you can see that this is now a boolean, right? It's now a boolean. Oh, okay. There's an error here. So yeah, so this, I don't know if someone can tell me what is the cause of this error we're having. Although there's already an error message here. But one thing I'm happy is that it hasn't gone ahead to tell me the right thing to do. It will tell me the right thing to do once I run the code, because the Rust compiler is like that, right? It guides you. It guides you every step of the way, right? So that you don't make much mistakes. But here I've made I missed something, and this is supposed to be a macro. but I missed something. So if anyone can guess what it is that I missed, I would really appreciate that. You can just leave that in the comment or something, and you can just guess what I would do to make this code working again. But I will just leave it like that and I'll move on. Yeah, yeah, makes sense. And yeah, the syntax is really easy, right? You see how simple it is. So, it's just like this guy is returning the value, right? So because of if left, I am able to kind of like destructure um maybe age, which is age. I can destructure it here and use it, to do whatever I want to do. I can then end up using it in that block, right? It's kind of it can be confusing in like when you're not when I wasn't used to this syntax, believe me, I could not wrap my head around it, right? I not that I couldn't wrap my head around it. It's what it took. I was kind of skeptical about using it, right? But later on, as I kept on using it, I began to see how it made a lot of sense, right? For me to just use iflet, unpack the option, get the value I need, and still use it in that block of code, right? So it made a lot of sense for me, right? So I can just do this, write a bunch of other stuff I need here, just go and write stuff, do what I need. I know that I have access to age inside of this block to do whatever it is that I need, right? So I'll just cut this out. So guys, if you can tell me what is the cause of this error, you can always go ahead. But the cause of this error is the fact that print line is a macro in Rust. And macros in Rust, you end them with exclamation marks, right? You end them with exclamation marks. So to confirm what I just said, I will go ahead and run this code. So I'll say cargo run and watch the compiler tell us that something broke. And let's look at it. So you can already see right here it says not a function. Print is not a function, right? It now goes ahead to say use exclamation mark to invoke the macro. You see the reason why I said Rust is kind of like exactly. Thanks, Frank. Thank you, Frank. Um, yeah, thanks, Frank. I'm trying to reply. Yes, yes. So yeah, so I missed the exclamation marks that makes it a macro, right? So back to what I was saying, you can see how the compiler is assisting me, right? Let's say for instance, I don't know what's broke in my code. I don't know. I've tried everything. I don't know. Before I even start going to the browser to go and Google or do whatever, I can just try to build and allow the borrow checker or the compiler to just direct me on the right things to do, right? And looking at this, right, you can see that it's already telling me where to even add the exclamation mark, right? So this is why I always tell people that for me, in my opinion, Rust is easy. In my opinion, it is easy because I don't think there are other languages that you have this level of detailed error messages. It helps a lot, right? Saves a lot of time, makes you more productive, right? Yes, it has a steep learning curve, but then again, I don't think there are many languages that have this kind of explanation when it comes to finding potential bugs in your code, right? So now I will now go ahead and add that exclamation mark there. If I save this, that error has gone. So now I will go ahead and I would run the code. Mhm. So clear this, I'll run the code again. Okay. So age is true, age is true. So you can automatically see that. Oh, I'll change this to change this back to 38. So Frank said the compiler is something else. Yeah, the compiler is amazing. C++ gave me shege with nonsense error logs. It's not only C++, right? So many other languages like JavaScript, you know, you would see weird error messages and stuff, right? So many other languages are like that. And this is one thing that sets Rust apart from most of these other languages is the fact that the error messages from the compiler is really, really, really helpful. Believe me, it is very helpful. But yeah, right. So thanks once again, Frank, for that comment. So I'll clear this and I'll run this again. So you can see that we have age is 38 and age is 38 running on the same line on different lines. So here is the one with if let's. So I'll just add a better comment. Say if let's age is this and match age is that. So save this and run it again. So we can be able to differentiate between the both of them. Yeah, so you can see match age is 38 and if let is 38. So yeah, so this is like, you know, the how we can use if let to, simplify match statements. We don't have to, write, an arm, like two arms just to handle one thing. We can just do it in a few couple of lines, and believe me, it gets simpler, you know, as it goes on. But one thing to take note of is this is not a direct substitute for match, right? You use this only when you're sure that you're expecting, you just want to handle one case, right? You have a situation whereby you want to handle multiple cases, it will not be advisable to use this. So this does not replace the match statement, right? It's just a way of saying, okay, trust me, I know what I'm doing. I just want to handle only this value. So I'll go ahead and wrap and give my variable or whatever an option type, and return an option type. Maybe from a function I'll return an option type, or maybe in a variable I'll give it the type of an option, and I will go ahead and use my sum to handle the case whereby there is a value, and use none to handle the case whereby there is no value, or allow the compiler to do that for me. So guys, that is that for that part. So next we'll be talking about is the let else. So I think we've taken so long on this stream. This might end up being my longest stream, but anyways, let's let's continue. So let's talk about let's else. Add the comment. Else. Okay. So let else is one of Rust's newer features. I think it came with language, I think 1.16. So let me check. Um guardrail. Okay, trying to check. Okay, someone said, how have I lived without let else? Okay, that's an interesting uh these things. I don't know how much people know about this, but this is RFs. This RFs is awesome. It can currently be enabled. Hi, welcome, Ibrahim. Um, it can currently be enabled on nightly compilers. Okay, this was like from 3 years ago. Okay, the question mark, blah blah blah. So this does not concern what we are doing, but one thing to take note of is that the let else is one of Rust's newest features. It acts as a guardrail, ensuring that your code does not proceed unless a specific condition is met. Right? Um, it's like saying, if you don't pay me my money, I'm out. Like I'm done. Right? It's like saying, okay, I've been working for you, but if you don't pay me my money for this month, I'm resigning. That's like that's basically what the if the let else um, does. It's kind of like confusing. I don't know. It confuses me, like because of the name. They have if let and let else and all that, right? But there is I think with enough practice and over time, you get to the point whereby you know you begin to get the idea. You can begin to get see the differences between these guys, right? Um, you can use this with option and result too when you want to do things like early exits, right? So instead of nesting multiple if and match statements, let else will just keep your code flat, right? To keep your code very flat. So let's look at an example. So say, um, hmm, okay, so let's say let sum all this, and I'll give it name. And here I'll say sum again. I'll define the name. I'll say captain, and I'll say else, and to print an error. So e prints. So e print is how you can print like an e print line. So you can print errors. So I'll say no name was found at this time, right? And after that, I want to return. I'll just return. Also add this here and save, right? So name is an unused variable. Okay, variable. So this is one way we can use this. I will still go ahead and use the name, right? But this is like, you know, this we can I can actually even do this in like one straight line, one straight weird line, right? Um, yeah, welcome Ibrahim. Welcome Ibrahim. Oh my god. What did I do? Okay, welcome Ibrahim. So guys, it's not easy. It's not easy coding at the same time, thinking at the same time, responding to text. So sometimes I might take a while to respond to your comments. Please forgive me, please. But once again, I'll say thank you guys for always coming on my stream. It's always a honor to have you guys here. Honestly, it's surprising that I will go live and I'll see a lot of people come on my stream. Right? Um, it is surprising to say the least, and I really appreciate you guys for supporting me in the best ways you can. And yeah, so just continue. So now, I can now go ahead and use that name. I can declare something like I'll say um, print line, and I would say hello. I'll pass my name here. Save this, and if I run this code again, cargo run. Yeah, so I'll get hello captain, right? So I get hello captain. No, that's not correctly spelled. Save it again. Yeah, hello captain, right? So if I let me see what happens when I don't pass any value in that place, right? So I should get the error print. So go ahead and tell me. Oh, nothing. Hmm. This invariant takes one argument but one zero was supplied. Okay. Save hello captain. So based on the definition I had given initially, like I said, um the let else, right? So let and else, you know, is kind of like saying if you don't meet a certain condition, I won't do this, right? So it's kind of like saying if you don't pay me my money, I'm not going to work for you again, right? And that's what is happening here. So if there is no name, right, it won't even run in the first place. It won't even work, right? So the situation whereby it works is when we are able to get that name from here, right? So if that does not work, we'll go ahead and say no, no name was found at this time, right? So I'm going to try as much as possible to move a little bit faster because um, so the let else, yeah. So the thing is, there are only much that we can use, right? There are only much you can use. Like me now, I stick mostly to the if and else. I stick to if let match, right? And sometimes while. Oh, thank you. So yeah, I'm glad that the money analogy helped. Um, yeah, I'm glad. I'm glad. Thanks, Captain. But I just stick to a few of them, right? There are already so much that you can use, but believe me, they all have their use cases. They all have their use cases. They all have their use cases, but I try as much as possible to just the idea is to always visit these concepts from time to time because they are really easy to forget. They are very easy to forget, honestly. But then again, let's move on. So next we're going to talk about whilet. So let me say while. So there are many. These guys, there are plenty. Whilet. Hmm, okay. So this one now is like using the match pattern, right? It's this the whilet continues to run as long as there is a match, right? So this can be used when you're iterating through like data structures in a stream or something like data in a stream or a collection of items like in a vector or in an array or something like that, right? While extracting specific values that matches your use case. So for instance, let's say we have a vector or an array of values from 1 to 100 and we want to get only the even numbers, right? Want to get only the even numbers or want to get only numbers that are divisible by 3, right? That is why we will use the whilet, right? So it's an elegant and concise. It is elegant and concise for situations whereby you are, you are processing elements until a certain condition is met, right? It reduces the need for you to do manual checks and makes the whole code um, cleaner, right? So let me go ahead and write an example of this. So let's say we have coins, and this our coin is going to be a vec, and in there would have, let's say, some. So this is sum again. So sum now is like sum, and at the end of the day is still an option type, right? So it's I'm going to infer it's going to infer the option type on the values that are in this vector, right? So sum, and I'll pass 1, and I'll do another one. I'll say sum, and I'll pass 2, and finally I'll end it with none, right? And I will pass this here. So you can see that it has already inferred it with saying this is a vector that contains option types of I32s, right? So we have different options inside our vector, and all of them are types of integers, right? So that's the reason why I'm able to have none here, right? Because none is also a variant of the option type, right? And they all happen to be in the vector. I know that's confusing, but guys, I'm trying my possible best to explain this the best way I can. But this is it, right? We have a box called vector. This box can only take English textbooks, right? This English textbooks in this case is the numbers, the vectors. So now we want to handle a situation whereby there are no books. We then wrap these whole books in an option, right? So now, as we've wrapped it in this option, we know that if we get a book, we'll handle it with some. Or if we don't get any book, we'll handle it with none and we'll keep quiet about the error. We'll just handle it, right? Say, okay, there was nothing inside. No need to panic. Everything is okay, right? That is what just happened here. And that is um the type for the coin. So the coin is a type of vector with option types that contain I32s. I don't know if that makes sense. Well, guys, please, if it doesn't make sense, you can watch this again and repeat what I just said. But yes, let me not waste much time on that. What have I done? So now um let's write code that using the whilet that would pop our coins, right, until we hit none, right? Just like I explained. Let's say we are looking for we have a vector of numbers ranging from 1 to 100, and we want to look for the ones that are divisible by 3, right? So that's where we use something like whilet. We'll continue doing that until we can no longer get any number that is divisible by 3, right? That is multipliable by 3 or divisible by 3. So it's still the same use case at the end of the day, right? It's the same use case at the end of the day. So let's just go ahead and write the code. So I'll say whilet sum, Again, I have another sum, and I'll pass my coin. So this is the coin. So there, I'll say coin dot pop. Remember, um, the vector has methods on it, right? So we have pop, push, and all that. So in this case, we want to pop, we want to remove something from our vector, right? We want to remove something from our vector. So we'll pop it out. So say coin dot pop, and here we'll just go ahead and print. So just print line. I'll say found a Kobo. Let me look for Kobo sign. Oh, so we don't even have Kobo sign. Supposed to have like K. We don't even have Kobo sign. Can you imagine? Anyways, let me copy this one Naira sign. So I'll use Naira. So here I'll just paste that. I have my 1 Naira found, 1 Naira coin. Okay, and I'll pass my coin here, right? Coin, coin, 1 Naira coin. My coin there, and yeah. So this should um this should go ahead and look through all the values in my vector, right? And tell us that we found, let me use something like 100 Naira. And okay, let me just use 10. 1 coin, 2 coin is fine. Let me add more. Let me add more. I'll say three coin. And this will be four. The comma. Save. So I run this guy. I'll go run. Should get what's happening? Why let some coin I dot pop found coin. Run this again. Supposed to get, am I not getting this in some? Maybe that would work. Let me see. Which one doesn't implement this standard? Okay. This. Okay. Hmm. Trying to understand. I don't know why this is not working. Understand why this isn't working. Hmm. It's weird. Um, why let some kind of pop. Okay. I think this is making it to skip. Let's try it again. Oh, okay. That's weird. That was very weird. So The reason why I couldn't see, it's kind of a weird situation that the whilet skips each of these um because we are popping and because it found none, right? So it skips it. But yeah, so you know what we've been able to do here with the whilet is to use it to kind of map. Is it map? No, to loop and get each of these value, right? So we found four, found three, you know, because we are popping from the vector, and we continue doing that until we got to the place where we found one. Not that I am sure of. Not that I am sure of. I don't think so. Let's look at the documentation. So there is a whilet here. The whilet. Yeah, it's not a bad question. Let's just look at the documentation, right? So this is loop. Okay, so this is for loops because it's okay. This is different from whilet. Um, no, but you can use an if else in it, right? But the whilet um syntax is just whilet, right? It's just whilet. So, but that does not mean that you cannot use like other this thing in it. But yeah, right. It's not. It wasn't a bad question at all. But this whilet is kind of tricky, right? It's kind of tricky, but yeah, um, you use it for situations whereby you want to keep matching. You want to keep make like you want to continue running as long as the pattern matches, right? Um, like I said, it is perfect for when you are iterating data in a stream or collection of data, and with extracting with situation where you want to extract specific types or specific values, right? Yeah. So so now we'll go over to loops. Um, so we'll go over to loops. So let's talk about loops. So for loops and ranges and stuff. So this will now take us back to what we had initially done here, right? So we had range, where we did the range stuff, right? Two between 2 and 200, right? So here, all the comments say for loops and range. Okay, for loops and range. Okay, so in Rust, loop is just loop, right? Loop is just loop. I keep hitting my speaker all the time. I don't know why. Okay, okay. So loop is just loop, right? But basically, it is a safe and concise and versatile way for us to loop through things, right? It's the easiest of all the syntax, right? And if you want to iterate over a range of collections or anything that implements the iterator trait, just use loop, right? Um, One of the importance of using loops is it prevents something there's something that they call by one errors, right? By one errors. It prevents that because Rust automatically handles the looping for us. So let's check what a by one error is. So off by one error. So the off by one error is a common programming mistake where loop iterates one time too many or one time too few, right? Often due to incorrect boundary conditions when dealing with array indices, resulting in incorrect calculations or accessing data outside the allowed range of an array. Essentially, the loop is off by one iteration from what is intended. So, key points about off by one errors causes usually happens when a programmer miscalculates the starting or ending point of a loop, um, often by using less than or equal to when they should just use less than or vice versa, right? And the impact of this can lead to issues like missing the last element in an array, accessing an element outside the array bounds, causing a crash, or producing incorrect results in calculation. So an example of this is if you look at here, we have incorrect loop. So for the integer equals to 0, okay, I less than or equals to the array dot length I plus plus. This loop will try to access one element beyond the array's actual size. So this one now is now the correct one where we have the 4 for the where the integer is equals to I, and I um is less than the array dot length I plus plus. Yeah, so in that case, yeah, so this happens to be the correct loop, and the reason is because of the difference is where they use um I is sorry, less than or equal to, and I think less than, right? Okay. I don't know what's happening to my monitor. Keeps going off and coming back on. Guys, hold on. I don't know what's happening to my monitor. Shit keeps going off. Okay. Yeah. So, guys, you can actually check out what the off by one error means. Let me just drop a tweet about this. Right. So say X. All right. So, guys, you can just you know read more about it. You know, and this is like a concept that we've all experienced, especially as JavaScript engineers, right? Where you write a loop, especially if you're into data structures and algorithms. This is something that you definitely experience, right? Where you write a loop like this, and less than or equal to or greater than or equal to, and you end up missing the value, and you have to tweak it, go around, tweak, trial and error until you are able to get the right one, right? So, like it says here, how to prevent, you have to double check, right? Double check your loop boundaries, right? So carefully consider whether to use this or this when defining your loop conditions. Understand array indexing. Remember that arrays are typically zero index, meaning the first element is an index of zero. Um, exactly. So that's the amazing thing about us, right? It pays attention to details. Um, you know, it has dealt, bro. Like, I'm telling you that's what like I said, if you are into DSAs in JavaScript, you would have experienced this thing a lot. I have experienced it a lot, where I have to check, tweak, go back and forth until I'm able to. It happens, and this is the things that makes me to like this language called Rust, right? Because of the attention to details. So, according to what we can see here, you can now see that you have to double check your error boundaries, right? When you're writing loops, you have to double check it and carefully consider when to use this. And when dealing with loop condition, understand array indexing, use clear variable names, and also test thoroughly at the end of the day, right? So it's something that you can definitely check out. And there's even a diagram here, right? and demonstrating the off by one error, right? So yeah, so what's how does Rust help us with this? So Rust using loop, right? Rust helps us to handle that, to prevent that situation, because it is handling it by itself. We don't have to start checking our error boundaries, right? All you have to do is just do something like this. If you want to loop, you can just loop, and I will say print line. My name is Chinedu, and that's all. This is all you have to do. You don't have to start trying to handle the error boundaries. You don't have to do none of that, right? This is all you have to do, and it runs and to run and it will keep running for eternity until you add a break or something. So let me run this and let's see. So you see, it will keep running, right? It just continues running. So let me break out of this. I don't need it to continue running. Right. So it will keep running and running. So I will just break out of this. And you can see, right, it's been running for a while. Um okay. Yeah, so you can see it's been running and there are a lot of it. A lot. Right. So that's the thing about Rust. So it helps you prevent that off by one error by handling the whole loop stuff internally for you, right? Which is part of what Rust is all about, right? Preventing stupid errors like this that we see in other languages, right? So I'll just go ahead and clear this. Yeah. Um, so another thing to take note of is that this works seamlessly with the Rust iterator adapter, making it very expressive and very powerful. So let's look at a couple of examples of how we can use loops. So guys, this life is going to 2 hours. This is a record. Um, God of Israel. Anyways, so let's iterate over a range, right? Let's say we want to iterate over a range of values, so from 0 to 5, right? If you remember, we did something about range here, right? When we looked at the master statement, and I said I was going to come back to it, and this is me coming back to it right here, right? So I would comment out this guy because he's notorious for um wanting to print till eternity. So I will just close this out. Then we'll start with for loop. Right? Let's look at for loop, an example of for loops. And Rust for loops also helps us with the off by one error, right? Because we don't have to do all those error boundary stuff. So it handles those things for us. So let me write an example. So I'll say iterate over a range. And here I'll say for I, which is the index. It can be anything. It can be A, B, C, D. It can be your name. But just convention, say I in 0 dot dot 10, right? For that, we want to print. So we'll print our I, print line, bracket, and this, right? So that's it, right? Doesn't implement the std trait. What's happening? Doesn't implement the std trait. FMT. Oh, okay. So I have to add um exclamation mark and question mark for that to be, yeah. So, oh, sorry, this should be I, exactly. So if I run this, what do you think would happen here, right? Would be able to print from 0 to 9, right? So I will also show a situation whereby we can print everything that is from 0 to 10. For now, let's just run this. I'll go run. So you can see we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can already see how I don't have to do all the weird stuff had to do maybe in other languages where I have to start handling the error bounds and stuff. I just have to specify my range, right? And it just works, right? It just works automatically. And this is one of the one thing that Rust does for us, which I've mentioned and I keep mentioning, the off by one error, right? Because Rust would manage the iteration for us automatically, right? So this is one. We can also add like an equal to here and run it again. Let's see what we get. So you see now it now included 10 because now it's just like us saying everything from 0 to 10, that is including 10 itself, right? So we are not just saying from 0 to 10 because we know it is indexed, right? So it will just give us 0 to 9. The situation whereby we want everything in that range, we have to add an equal sign, right? So that equal sign will then, you know, give us everything that we need, like in that range. So from 0 to 10, right? So for the purpose of learning, I'll just copy this and paste it again here, and I'll remove the equal sign, save, and cargo fnt to format the code, and cargo run once again to run, and we'll see the difference between both of them. So we can already see the difference, right? So we have 0 to 9, and we have for the second one where we have 0 to 10, right? So yeah, so that's for that. So I'll just comment out this line. Yeah, I know Ross will tell me that I'm not using the I variable. Yes, but don't worry. Let's move on. So now let's look at how we can. Somebody said JavaScript, anyhow language. but but I still love JavaScript, right? JavaScript is I still love JavaScript regardless, right? Rust is what it is. JavaScript is what it is. They are all good in their respective ways. Anyways, let's go over. Let's continue. I mean, so I'll say let's iterate over a collection over a collection. So in this case, we'll create a collection and we'll just create a collection. We know that it's similar to like an array, but it is a vector. And my Rust analyzer will specify that. So I'll say let's create a fruit, and in this fruit we'll have uh, apple, we'll have banana, orange, and mango. Am I writing today? Mango. So and it's with this. Okay, so we have an array of string slices and sorry, a vector of string slices and index of three. So one, two, three. Right. So that's what this thing means. Right. I can manually add it by myself. I can just double click and it would insert it there by myself, by itself, right? But it's too verbose. So most times I just go ahead and without declaring what the variable type is or what is speaking to. So now using our for loop, how are we going to iterate over this collection? Right. So it's still the same way we did here, right? It's still the same way we did it here. So we'll just let me just copy this guy. I think I already copied it. So I'll paste it here. Exactly. And here I would say instead of using I, just to make it more relatable, I'll use fruit. So I'll say FRIUT fruits in my fruit. So no, this would be fruits. That is plural, and this is singular. That is fruit in my fruits. Dot iteration. So I want to iter, right? So I want to iterate over it, right? And at the end of the day, I want to print my fruits. So just fruits FRUT. I don't know if I'm am I spelling today. FRUIT. See FRUIT. Okay. I don't know what am I even spelling today. You get the point, like, right? You guys get the point. So let's just move on. Not wasting much time. So I would clear this and run. I go run. So you can see I have apples, orange, and mango. So I've been able to iterate over, um, you know, my collection. And you might be wondering where is the iter method coming from. So the iter method is a method on this, right? Is a method on on the vector, right? Or what I say an array or something. So let's look at um iter in Rust. Iter Rust. Okay. Method that we can use on hmm, okay. This is example. Hmm. Array slice methods in Rust. Hmm. Oh, I can't start diving into this thing. We don't have a lot of time for that. But I would get back to this, right? We don't have a lot of time. This stream has already gone way above the time I planned. This is the longest I've ever streamed. But then again, the iter method um returns an iterator over the slice, right? So the iterator yields all items from start to the end. So yeah, that's what it is, right? So it's an array slice. So next, we'll then go ahead and talk about. There's so many other examples I could give, but in the interest of time, the stream has really lasted long. This is the longest I've ever streamed. So we'll now talk about the last guy, which I already visited initially, which is the loop, right? So I'll talk about it with while. So like I said, loop is designed to be infinite, right? It should run forever, right? Um, unlike unlike while loop, unlike while loops guarantee at least one iteration and doesn't require a condition upfront. It will just keep running and running, right? So you can use it for instance, if you've done anything that has to do with I think um, games like game loops, right? Server or tasks where you would break out when a certain condition is met, right? Or when you are retrying an operation like a network request or waiting for an external signal or something. That's why you use something like loop. I already showed like an example of it here, and it also has like a break where you can. There's also a situation whereby you can break, right? So let's say there's a break element that you can use with loops, right? So you can break off when a certain condition is is met, right? So let's now compare it with the while, right? So while now, I would prefer using while because I kind of like it kind of makes more sense to me. I guess because coming from JavaScript, it kind of makes more sense to me, right? So I can easily say, let me create a variable, a mutable variable. I'll call it count, and this count is going to be equal to 0. So I can go ahead and do something like where I will say while my count, my count is less than 3, right? When my count is less than 3, I want to print. So I want to print count, the print count here, and then I'll do my incrementing, right? So count plus equal to 1, blah blah blah, and save, right? So based on my maybe my my background in JavaScript, so this makes more sense to me. Loop still makes a lot of sense, right? But you know these two make sense, right? In my own opinion, right? So I will just go ahead and comment out this guy, and let's run the code and see what happens, right? So I'll end this with semicolon um, and save. So I'll run this code. Clear first of all. What's the need of clear? No need. So let me just run the code. Cargo run, and yeah. So you can see, right? So when the count was 0, and this B here. So the count was 0, right? So the first time that this while loop runs, it was 0. It ran for the second, and it ran, and it added 1, right? The count became 1. Then it ran again. It checked, saw that it was 1. It added on. It printed the second one, which is 1, which is the value, current value, because remember we had increased it from 0 to 1 in the first um, like the first time that the while loop ran, right? So now we then printed 1 and increased the count again by adding 1 to the one that was here that we had done the previous time. It became 2. Then we ran this line again to check if count, which is in this case 2, is less than 3. It is true. We printed it 2, right? Then incremented it now to 3. Then we checked while count is less than. We know that that condition is not true. Now it's now false because count is now 3 and it's no longer less than 3 because they are equal. So at that we just broke off from that point, right? That's where we stop printing. So I can go ahead and say less than or equal to, and you will see that we'll print both 0, 1, 2, and 3, right? If I save this, I run the code. Exactly. So you can see now that we run 0, 1, 2, and 3, right? So yeah, guys, I really went very deep today, talking about Rust pattern, Rust matching pattern, and you know the philosophy and everything behind it. Um, if you had followed me from the onset, you would notice the safety and expressiveness of the language and how it handles the flow and the control flow and everything, right? Um, the compiler, right, um, helps us to prevent bugs. That was something I was able to demonstrate in our several builds. And whether you're coming from a different language, maybe like JavaScript or Python or whatever, you can immediately see similarities, right, in everything that I've done here today, right? You can begin to see 2 hours, my guy. You can begin to see the similarities between these codes. So, guys, I just want to say thank you so much for joining me, Captain. I really appreciate Maz, Frank, Dara, the rest of you guys, Ibrahim, who have been engaging and who made this stream really interesting. Believe me, if not for these comments, right, I would have. I don't think I would have been able to stay this long because it's more engaging when you're doing these live streams and people are asking questions, and I'm trying my possible best to give answers. Captain asked a couple of questions. Frank, um, you know, made had a lot of some comments that he made, which were very helpful and all that. So, guys, I would say thank you so much for joining me on this live stream. Um, it's not easy to do these things, right? But because it's something that we enjoy doing, and that's why you can see someone come and binge watch my live session for 2 hours. Someone like Captain. So, guys, I would say thank you so much for being here with me. And yeah, I think I will just put on my maybe my music and let the whole thing play for a while. But I think we've come to the end of this stream, and I will see you guys later in the evening. And when we'll talk about options and results, the similarities, the difference between them, when to use them and when not to use them, and why we have you know two enums that solves almost the same problem, that are similar, solving the same problem. Why should we even have them in the first place, and what they do, right, and the right time to use them? So once again, thanks guys for joining me on this one. I really enjoyed doing this with you, and I will see you guys later today. Bye.